Okay guys, for homework tonight, we are going to finish our binomial expansion notes that we started in class today. So you guys should have your interactive notebook pulled up. We already filled in our table of contents during class time today, page 13 to 15 binomial expansion. We already took all of these notes in class today. We're just going to do a couple more problems where we use Pascal's triangle and find terms. So you did these examples today in class. You should have posted those right here on slide 14 on that right hand side. That was these ones that we just wrote on a piece of paper. We already did a couple of the examples, but we're going to go ahead and finish the last two. So example 1 we didn't do. It says use the binomial theorem to expand 6x plus 2y cubed. All right, so following the steps, okay, the first step is to use the exponent to match Pascal's triangle row. So we have an exponent of 3. So we need to create our Pascal's triangle to that row. I don't really expect you guys to create it every single time. You could look at the Pascal's triangle, but you should know how to create it. So you start with a 1, and then it always has one extra term on your next row. So it's just 1 and 1, nothing in the middle. Then you put 1s on the outside, and then you add these two terms to get the middle term. So when I add 1 plus 1, I get 2. That's row 2. You'll know you're at row 3 when the second number is a 3. So I put 1s on the outside. And 1 plus 2 is 3. 2 plus 1 is 3. And that's row 3. We know that because the second number is a 3. Whatever the exponent is, there's always going to be one more number than that. So it's row 3, but it has 4 numbers. Okay, so that's what we're going to use. We're going to use this 1, 3, 3, 1. Notice how I leave a bunch of room in between. All right, then you take your first term, which is 6x, okay? So 6x. All of our other examples, I never gave you any where it had a coefficient with a variable. So when it has a coefficient with a variable, you're going to actually want to put parentheses around it. So I'm going to put 6x to the power of 3, and then we work our way down. So next one's 6x to the power of 2. 6x to the power of 1, and then the last one doesn't get any at all. All right, then I'm just gonna move my 1 really quickly. Then when you use your second term, working backwards, that's a 2y. You start at the end, it has a coefficient, so I'm gonna put 2y, the exponent is 3, and I'm gonna work my way backwards, 2y to the power of 2, 2y to the power of 1. Okay, so the reason why I saved this one for our homework is because there's actually a lot more simplifying when there is a coefficient in front of a variable. So here, see how it says 1 times 6x cubed? Well, the 6 and the x, this is really 6x times itself 3 times, right? So that's what it means when you cube something, you multiply by itself. So you do have to do 6 to the power of 3. So this is the 3 kind of gets distributed on both parts. So it's really 1 times 6 cubed times x cubed. They both get it. And then plus the next one has a 3, so it's 3 times. You'd have to distribute the 2, so it's 6 squared times x squared. The 1 really doesn't get multiplied, but 2 times y, or the 1 doesn't really get distributed, I mean. And then plus, our next one we have is 3 times. The 1 doesn't really have to get distributed, so it's 6 times x. The 2 does get distributed on both, so it's times 2 squared times y squared. And then the last one is plus 1 times. The 3 gets distributed onto both, 2 cubed times y cubed. Okay, so we got to simplify here. So we evaluate each term. So 1 times 6 cubed, well 6 cubed is 216, and then times 1 is just 216x cubed. Plus, now we got to multiply 3 times 6 squared, but also times 2. So that's 3 times 36 times 2, which is also 216. And here we have x squared and then a y, so x squared y. Okay, plus here we have 3 times 6 times 2 squared. 2 squared is 4. 3 times 6 is 18, so 18 times 4 is 72. And then we have xy squared. And And then our last one is 1 times 2 cubed. 2 times 2 times 2 is 8, and 8 times 1 is just 8. And then we have a y cubed, and that's our final answer. So whenever there is a coefficient in front of your variable, like our problem up here had a 6x and a 2y, what you need to remember is that the exponent, when you go like you're decreasing order with the exponent, you have to put parentheses around it and it gets distributed onto both. All right, we have one more example to do, and that's example 3. It says find term 4 in the expanded expression of 4x minus 9y to the power of 7th. So the way that I kind of do these ones where it's find term 4 is I just kind of like set it up as if I was going to find all of them, but I only actually multiply out kind of like term 4. So first you would start off with your exponent. My exponent is a 7, so I'm going to go ahead and I already know Pascal's triangle row 7. It's down here on example 4, and it was also on, it's on slide, what is it, 13, but it's 1, 7, 21, 35, 35, 21, 7, and 1. Okay, then I'm going to take my 4x. Remember, it gets parentheses around it, so it'd be 4x to the power of 7, 4x to the power of 6, 4x to the power of 5, 4x to the power of 4, 4x to the power of 3, 4x to the power of 2, 4x to the power of 1, and then the last one doesn't get any. And then we have a minus 9y, you got to put the sign with it, and it would work backwards. Negative 9y to the power of 7, negative 9y to the power of 6, negative 9y to the power of 5, negative 9y to the power of 4, negative 9y to the power of 3, negative 9y squared, negative 9y to the power of 1. All right, well, we only want term 4, right? So it says find term 4. So this is term 1, 2, 3, 4. So this is the term that we want right here. This is the one that we want. 35 times, remember you distribute the 4, 4 to the power of 4 times x to the power of 4. You would distribute the 3, so negative 9 to the power of 3 times y to the power of 3. That's what we're going to multiply. All right, so we're going to get a super duper big number. When you multiply 35 times 4 to the 4th times negative 9 cubed, you're going to have a positive or negative number if negative 9 is an odd exponent. It's going to be negative because it's odd, so it's actually negative 6,531,840, and then your x to the 4th y cubed. That's our answer. So I don't want to multiply out any of the other ones because those are super big numbers. So I just kind of list out all of them, but then I just go to term 4 because that's the one they want, and that's the only one I multiplied out. So it was 35, and then the 4, the exponent got distributed, so 4 to the 4th, x to the 4th, and then the 3 got distributed, so negative 9 cubed, y cubed. Multiplied out my 35, 4 to the 4th, negative 9 cubed. You could do it all on your calculator even, but it's negative 6,531,840, and then x to the 4th, y cubed. Those are all of the examples for the binomial expansion one. So what added today that wasn't, or added tonight that wasn't on our notes today, is if there's a coefficient in front of your variable, you do have to distribute your exponent onto both. So these two notes that are from your workbook should get put onto slide 15. So you just take all this stuff that's here and you kind of just delete it out, and then you want to put those actual examples here. Those examples that you did don't go on to your like class assignment for today. The example problems always go into your notebook. Okay? So I think that's it. You guys did have a couple problems that you were supposed to do earlier, and those problems were supposed to get attached to your classwork. That's it for our notes. We're going to do some practice tomorrow in class.